Good afternoon, everyone. So we are doing insolation and temperature. One quick understanding of this insolation wala part. If this is the sun, right, and the earth will go around the sun. So sometimes the earth is here, sometimes the earth is here, sometimes the earth is here, and sometimes the earth is here. It revolves around the sun in an elliptical manner. चाहे हमारा diagram may be bit circular, it does not matter. The earth is inclined at an axis of 23.5 degree. So this is how the earth ka north and south are inclined, right? And because if this is the north and south, then this is the equator here, this is the Tropic of Cancer, this is the Tropic of Capricorn. Equator, Tropic of Cancer, Tropic of Capricorn. Same. So 0 degree, 23.5 degree north, 23.5 degree south. 0 degree, 23.5 degree north, 23.5 degree south. Now because the earth is inclined at an axis and also it is rotating and revolving, so sometimes the sun rays directly fall on the Tropic of Cancer. You can see the sun rays are falling mostly between the Tropic of Cancer and the equator. And as a result of this, what we can see is in the northern hemisphere, जो आधा portion है circle का वो उसको light मिलेगा, the remaining half portion will be dark. So as a result, you can see the northern hemisphere ka most of the portion is in the light, and we call this, when the sun is directly overhead the Tropic of Cancer, we will call this as the solstice. देखो ऑप्शनल में इसकी इतनी ज़रूरत नहीं पड़ेगी, but this is what is known as solstice, which occurs on 21st of June, but this is just for your understanding, and this is the summer solstice because we in the southern hemisphere will have summer season here. What will happen in the summer solstice in the northern hemisphere, exactly on the 21st June, this will be the longest day and the shortest night in the southern hemisphere. Fine? On the 21st of June, because the sun is directly overhead on the Tropic of Cancer, एक दो lectures के बाद मुझे ये लगेगा, can I say heating maximum is occurring over the Tropic of Cancer? Insolation सबसे ज़्यादा क्या हो रहा है over the Tropic of Cancer. So the insolation, when it is captured by the sun and then when it is converted into the form of heat, उसको हम कहेंगे temperature. That is the basic difference between the insolation and the temperature. Captured insolation, then converted, or the capture radiant heat of the sun and then converted, is what is the temperature. And therefore temperatures are very high during this time, and we will say in the Indian monsoon, this is the time when ITCZ will shift over the India. अब क्या है ITCZ? ITCZ टेक्निकली देखा गया तो इज अ लो प्रेशर सेंटर जो हमेशा इक्वेटर पे होता है. What happens in this ITCZ? Side view अगर मैं बनाता हूँ, at 0 to 5 degree north and 0 to 5 degree south from the equator, winds will come and they will get heated because sun ज़्यादा है, and इसीलिए यहाँ पे हवा ऊपर जाएगी, इससे winds आएगी, they will get heated and the air will start rising upwards. So ITCZ is a low pressure center क्योंकि हवा ऊपर जा रही है. Fine? And where it is present? It is basically present near the equator, ideal conditions में. But reality में where is ITCZ? ITCZ is just directly below the sun. The part which gets the maximum amount of sun rays is the region of an ITCZ. So we will say ITCZ has shifted towards India, and this is the region. Why it is known as ITCZ? It is known as ITCZ because it is located in the tropics, intertropical. It is the zone जहाँ पे trade winds of the northern hemisphere and the trade winds of the southern hemisphere are converging, and therefore it is known as a convergence zone, ITCZ. We will say this is the season when the southwest monsoon will begin in India. फिर entire India will become a low pressure region. As the entire India becomes a low pressure region, India में बारिश शुरू हो जाएगी on the 21st of June, and then we'll see the jet streams जाना शुरू हो जाएगी. There will be no longer a jet streams. See, from 2-3 days, nights will have started becoming cooler. If you have habit of sleeping out in the open, the dew drops have started falling down. This is because अब retreating monsoon या winters will start coming in over India. Why it is so? Because right now the earth is revolving in such a manner around the sun कि the sun rays are falling directly over the equator. This is how right now the earth is. The sun rays are falling directly over the Tropic of Cancer, and the sun is rotating. So earth is rotating. So you can see northern hemisphere, North Pole has more than 24 hours of day. South Pole has more than 24 hours of night. Ab earth has come here in this position, and therefore the sun rays are falling exactly at the equator. Because the sun rays are falling exactly at the equator, the sunlight is equally distributed, and therefore between the two halves. So I am shading this part. यहाँ पे during the each and every there will be exactly 24 hours of day and 24 hours of night, और इसको हम कहेंगे as equinox, जो अभी होने वाला है on the day of 23rd September. In this position, during the equinox, the ITCZ will shift back to its original position. मतलब धीरे धीरे इंडिया के ऊपर का लो प्रेशर will shift downwards. सन नीचे जा रहा है. सन मतलब क्या है? Actually the earth is going downwards. So therefore we say that ITCZ will shift now. As the ITCZ is now going to shift, therefore we will come under the influence of westerly, not easterly, westerly jet stream जो वेस्ट से आती है. And what is to the west of India? Pakistan. Pakistan के वेस्ट में क्या है? There is Iran, Afghanistan, and this is the colder regions, cold desert regions है ऊपर की तरफ, and इसीलिए कल परसों से थोड़ी ठंड होना शुरू हो गई. Understanding? अब इसके बाद there will be temperature inversion, which is our today's topic. After the temperature, there will be temperature inversion. Why equinox? Why this is known as equinox? Because equal day and equal night. Why equal day and equal night? Because the sun rays are falling exactly at the equator. कहाँ पे होगा equal day and equal night? Each and every place on the earth, including the poles, equator, tropics, subtropics, each will have 12 hours of day and 12 hours of night. Then the earth will revolve, and it will come to such a position that now the sun rays will be falling directly on the Tropic of Capricorn. And because the sun rays are falling directly on the Tropic of Capricorn, during this season we will have winters. Why we will have winters? Because याद रखना परसों का lecture insolation का, wherever the sun rays are directly falling, vertically falling, that is the region which is going to receive maximum insolation and therefore maximum heat. Because the sun rays are not falling directly over the equator or over the Tropic of Cancer, but it is falling to the southern hemisphere, हमारे तरफ sun rays are becoming more and more inclined. वो directly perpendicular इधर है, so हमारे तरफ, look at the curvature of the earth, they are becoming more and more inclined, and because they are becoming more and more inclined, again in solstice, but with reference to the northern hemisphere, this is the winter solstice. कब होता है? On 22nd of December. What happens during the winter solstice? Again the half of the earth. यहाँ पे कभी लाइट नहीं पहुंचेगी, यहाँ पे लाइट कम पहुंचेगी. The North Pole will have 6 months of night time. वहाँ पे South Pole was having the 6 months of night time. यहाँ पे because it is the southern summers, this is going to be the southern summers, therefore the South Pole is going to have more than 24 hours of day. मैंने 6 months इसलिए यूज किया क्योंकि यहाँ से यहाँ तक आगे. And this is our winter solstice, shortest day, longest night, and this is the season when India is going to experience large scale temperature inversion. Fine? क्योंकि ITCZ कहाँ पे है? ITCZ is in the southern hemisphere जहाँ पे Tropic of Capricorn है. So Tropic of Capricorn is this line. So ITCZ is over Australia. And lastly, again, the equinox. But this is spring equinox. Which is going to be on 21st of March. So can I say variation in the insolation? So यहाँ पे भी equal day and equal night. But right from 22nd of March till 23rd of September, at the northern poles, there will be diffuse daylight, 6 months of day. Southern poles पे there will be no light, for 6 months of night. यहाँ से वहाँ तक there will be exactly opposite. So can I say variation in insolation क्यों है? Due to both rotation of the earth on inclined axis and revolution. Imagine karo if the earth would not have been inclined, sun, earth, 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 had the earth not been inclined, ऐसे ही होता straight north and south, sun rays would have always fallen over the equator, here also over the equator, here also over the equator, here also over the equator. So seasons नहीं होते, and this is responsible for seasons. And seasons means variation in the length of day and night. Clear? Concept, nothing but conceptual understanding you should have regarding this topic. Clear? If you want to draw, you can draw also. These are the cropping seasons in India. This is month में Kharif, the summer season, rainy summer season, southwest monsoon season. This is what is known as southwest monsoon. This is the retreating monsoon. This is winters, and this is the dry summer season. Can I continue? Now just remember 2-3 things. Can I rub this part? This season is southwest monsoon. This season is retreating monsoon. Which has the dominance of tropical cyclones. Unlike अपने पहले के 2 topics, you should not study for climatology. You should understand climate, and then except for Köppen, Thornwright and stability, instability, बाकी सब कुछ conceptual है. रटने की ज़रूरत नहीं in the climate section. Fine. This is winters. In both winters and retreating monsoon, there is a dominance of northeast monsoon winds. इस समय बारिश कौन से देती है? साउथ वेस्ट मानसून विंड्स, ऑन शोर नॉर्थ ईस्ट मानसून विंड्स. कैन आई कंटिन्यू? एंड यहां पे दिस इज ड्राई समर्स. इसको हम मानसून के नाम से नहीं देते, वी जस्ट कॉल इट एज अ ड्राई समर सीजन. Fine. Again, temperature. Can I say temperature? There is a, if you look at the world map, इक्वेटर से पोलर रीजन पे जाओगे या इक्वेटर से पोल्स पे जाओगे तो टेम्परेचर वेरी कर रहा है या सेम है? वेरी कर रहा है. दिस इज व्हाट इज नोन एज हॉरिजॉन्टल डिस्ट्रीब्यूशन ऑफ टेम्परेचर. And if you go from ground to the top, that is what is known as a vertical distribution of temperature. So one thing, that is the temperature is defined as the temperature is defined as sensible heat, is defined as the sensible heat, is defined as sensible heat which has horizontal and vertical as well as seasonal variations. Was there variation in insolation from the sun? Solar constant same tha. Temperature mein there is a, though the insolation is going to be more or less same from the sun, the energy which is coming is same, but there will be variation in the terms of temperature, right? The temperature of the earth is because insolation is converted into sensible heat energy by the processes of point number 1, direct solar insolation. Point number 1, direct solar insolation. मतलब डायरेक्ट सनलाइट. मोस्ट इंपॉर्टेंट या लीस्ट इंपॉर्टेंट? GS, direct solar insolation is the most important way of heating the atmosphere या least important? Least important. Why? Because it is coming in the form of short waves. Bracket में लिखना 14%. Only 14% of the sun's energy is absorbed by the earth. Second, conduction. What do you mean by conduction? Transfer of heat through molecules, through touching of molecules. Is it an important mechanism for heating the atmosphere या not an important mechanism? Air में molecules can easily touch each other. नहीं, एयर के मॉलिक्यूल्स अगर टच होते तो एयर वुड हैव बीन सॉलिड लाइक दिस. अगेन अ बैड सोर्स ऑफ हीटिंग द एटमॉस्फेयर. मॉलिक्यूल्स टच नहीं है इसलिए तो हवा है ये. द मॉलिक्यूल्स टच, डेंसिटी इज हायर, इट बिकम्स देन सॉलिड. सो बैड सोर्स ऑफ हीटिंग. नेक्स्ट, थ्रू टेरेस्ट्रियल रेडिएशन. Through terrestrial radiation. In the form of long waves, in the form of long waves that are captured by the greenhouse gases. Terrestrial radiation in the form of long waves that are captured by the greenhouse gases. This is the most important source of heating the atmosphere. This is the most important source of heating the atmosphere. Fourth, ये मैंने आपको बताया ही था, अर्थ विल लूज द हीट, दैट विल बी इन द फॉर्म ऑफ लॉन्ग वेव्स. फोर्थ, कन्वेक्शन. कितने लोगों ने आंसर लिखा रिगार्डिंग डिफरेंस बिटवीन इंसोलेशन एंड टेम्परेचर? नो वन एल्स? हैव यू रिटन ऑल दिस मैकेनिज्म्स? This should come in the answer, right? We are not writing GS का answer कि insolation is the sun's energy. Insolation comes only in by the process of radiation, short waves. But temperature is by all these processes. ये सब आना चाहिए technical. That is in the answer. By the convection. What do you mean by convection? What is convection? सिंपल फिजिक्स वाला डेफिनेशन कन्वेक्शन का. कैसे? बट हाउ? कहाँ पे हमने पढ़ा था कन्वेक्शन? मैग्मा. तो कन्वेक्शन में कन्वेक्शनल करंट्स, खुद मैग्मा ऊपर आता है, खुद गर्म मैग्मा ऊपर आता है. दैट इज व्हाट इज कन्वेक्शन. जब मटेरियल खुद ऊपर चला जाता है. जब आप चाय बनाते हो खुद पानी ऊपर आता है, दूध ऊपर आता है. दैट इज व्हाट इज कन्वेक्शन. कंडक्शन by touch of molecules, convection when the transfer of mass itself occurs. So इसलिए जब हवा गर्म होती है तो हवा ऐसे ऊपर जाती है, and we call this as a low pressure belt. This is what is convection. Convection, the process of transfer of heat energy through the movement of substance from one place to another. Through the movement of substance from one place to another. The convection more or less depends upon insolation. याद रखना, convection more or less depends upon insolation. Because air coming in contact with hot ground surface air coming in contact with the hot ground surface becomes warm, rises upwards, becomes warm, rises upwards, comma, cools adiabatically. जिनका GS हुआ है, they know these words, adiabatic cooling, etc. I'll tell you what is. Cools adiabatically, becomes denser, and descends, forming low pressure and high pressure belts, Look here, air coming into the contact with the ground surface becomes lighter, rises upwards. As it rises upwards, after reaching the tropopause, it will cool adiabatically, heavy हो जाएगा, tropopause के ऊपर नहीं जा पाएगा, so दो डायरेक्शन में थ्रो किया जाएगा. It will then move and ऊपर जाते जाते it will become very heavy कि it cannot travel, वो descend होगा, and जहाँ पे वो descend होगा, this will result into high pressure, this will result into low pressure. So low pressure is associated mostly, not always, mostly with adiabatic heating, and high pressure मतलब air is coming downwards. Fine? Full stop के बाद adiabatic cooling, heating, adiabatic cooling, heating the ground, adiabatic cooling, and then adiabatic heating. I will come to that. That is the last point. What is adiabatic? Forming high pressure and low pressure. Likha? And thus then the air moves horizontally on the ground. Air moves horizontally on the ground from high pressure to low pressure. This horizontal movement of the air is known as winds. Air moves horizontally on the ground from high pressure to low pressure. This horizontal movement of the air is what is known as winds. Clear? Winds is always horizontal movement of air. Look in the diagram. इसको हम कहेंगे surface winds, इसको हम कहेंगे upper air circulation, इसको हम कहेंगे convection. This is descent. जो air ऊपर जा रही है, is it going away from the source of heat, that is the earth? Right? As it is going up, is the density of the air changing? ऊपर की air, is it lighter? So what are the mechanisms of the transfer of heat? Conduction, radiation, the most important. So when the air is going upwards, it is going away from the source of the heat, that is the ground. Ground is giving the terrestrial radiation which is coolly heating the atmosphere. So जैसे ऊपर जा रही है, it is moving away from the source of heat. As it is going up, air is becoming lighter and lighter because the weight of the atmosphere is decreasing. The weight of atmosphere is maximum near the sea level. It is decreasing, and if air is becoming less denser. दैट इज कंडक्शन प्रोसेस होगा नहीं. डेंसिटी अगर ज़्यादा है, molecules will touch each other. Density if it is less, molecules will not touch each other. There won't be conduction process, and therefore air खुद ब खुद cool होती है without somebody reducing the temperature. ऊपर जा रही है, ठंडी होते जा रही है. क्यों? क्योंकि वो सी फॉर एग्जाम्पल, आपने बर्तन रखा गैस पे, आफ्टर सम टाइम यू टेक द बर्तन अवे फ्रॉम द गैस, उसको आइस में मत रखो, फिर भी वो बर्तन कूल हो जाएगा. इन स्पाइट ऑफ यू नॉट पुटिंग एनीथिंग एक्स्ट्रा टू कूल इट सच एज हॉट वाटर, फिर भी टाइम के साथ दैट वेसल विल बिकम कूल्ड. दिस प्रोसेस बाय विच द एयर मासेस get cooled or warm just by rising up or by coming down is what is known as adiabatic heating and cooling. कोई और उनको cool या warm नहीं कर रहा है, वो खुद ब खुद हो रहे हैं, because either they are going upwards and therefore बस ये चीज़ें याद रखो, ये पूरा concept है. If you remember this thing, पूरा climate is easy. ऊपर जाएगा तो what will happen to the air? Heating or cooling? Cooling. जब भी air नीचे आएगी तो what will happen? Heating. This is what is known as adiabatic heating or cooling. Fine? Adiabatic change. Change just by ascent or descent is adiabatic. Fine? Non-adiabatic is हवा को किसी ने लिया, उसके ऊपर बर्फ डाला और फिर वो कूल हुआ, that is non-adiabatic. For example, अगर ये गर्म हवा है, if it comes in the region which is full of snow, so वो क्यों कूल हुई? Because it comes in the contact with snow. That is non-adiabatic. So always the air which rises upwards or cools down, it will be known as adiabatic heating and cooling. And therefore our fifth point, अभी तक clear यहाँ पे? Everything? And therefore our fifth point is adiabatic heating and cooling. Adiabatic heating and cooling, and this is the part which will come for as a question. इसके पहले वाला may not come as a question, but this can surely come as a question. The heating and the or the cooling of an air, heating or cooling of an air, heating or cooling of an air, either by ascent, either by descent or ascent respectively. Heating पहले लिखा है तो descent, either by ascent or descent respectively, is known as adiabatic change. Is known as adiabatic change. Now before I go further, tell me what is latent heat. Why is the word latent heat used? What? Hidden है. कहाँ पे hidden है? किस में hidden है? किस में? And water too? Solid, that is ice. All three are right, but there is some basic difference in the answer. Then water, then vapor. अगर ये चीज़ें समझ में आ गई अभी तो you will understand dry and wet adiabatic lapse rate. Understanding? How much amount of calories are required to change 1 gram of ice into water? Any idea? How much amount of calories are required? Somewhere around 70 calories. are required to change 1 gram of ice into water. So water ज़्यादा गर्म है as compared to ice, क्योंकि उसने वो 70 calories extra which you have supplied to the ice is stored in the water. And to change 1 gram of water into vapor, how many calories are required? It requires 607 calories to convert water into vapor. For example, I take a ice here and put it outside. वो थोड़ा थोड़ा मेल्ट होते जा रहा है, and इसलिए ये गीला होते जा रहा है. This is something which is very very cold because it does not require much heat. But will this water get evaporated on its own? If I keep this glass as it is in the classroom, कल हम आएंगे तो उसमें पानी होगा. बट अगर मैंने किसी और बाउल में इफ आई पुट आइस, कल हम आएंगे तो वो आइस नहीं होगा, इट वुड हैव मेल्टेड. Why? Because to convert water into vapor, it requires huge amount of energy. This amount of energy which you supply is stored in the vapor, and this amount of energy which is stored in the vapor is generally not seen, and therefore it is known as latent heat. इसका ये मतलब है when the vapor will get converted into water, it will release 607 calories, which is generally not seen. Fine? So, अगर ऊपर जाने के लिए एनर्जी चाहिए, तो किस में एनर्जी ज़्यादा है? आई एम आस्किंग यू इन वेरी सिंपल मैनर, विदाउट एनी साइंटिफिक एनालिसिस. जस्ट टेल मी बाय कॉमन सेंस, अगर किसी हवा को ऊपर जाना है, देयर इज 2 टाइप्स ऑफ एयर, ड्राई एयर एंड मॉइस्ट एयर. अगर कोई हवा ऊपर जाना चाहती है तो कौन सी ज़्यादा ऊपर जाएगी, मॉइस्ट एयर या ड्राई एयर? वाई मॉइस्ट एयर? Because moist air has trapped the heat in the form of vapor, and because it has trapped, understanding, there is a dry air and there is a moist air. So who has trapped more heat? Moist air, because water vapor has got converted into water vapor, and moist air ज़्यादा ऊपर जाएगी, right? Because it has more heat, and जितना ज़्यादा heat उतना ज़्यादा डेंसिटी या उतना कम डेंसिटी? जितना ज़्यादा हीट, the more the heat, is it more denser या less denser? Less denser. So याद रखना, आज से अगर किसी ने आपको जनरल क्वेश्चन पूछा कि गरम कि if which is more heavier, dry air या moist air? Dry air is more heavier, moist air is more lighter. Understanding? हमें ऐसा लगता है moist air is more heavier क्योंकि उसमें water vapor है इसलिए वो नीचे आएगा. No, moist air is lighter than the dry air. Very common question for geography optional student in interview. Most common question. Understanding? Which air is lighter, moist or dry? Don't use the logic. कि उसमें तो moisture है इसलिए वजन ज़्यादा होगा. Moist air is lighter. Why? Logic is it will expand because it can trap heat. The heat which is not seen due to latent heat. Understanding? अब dry air ऊपर जा रही है. Understand? If the dry air is going up and the moist air is going up, which has more heat? Moist air. Fine? Which has less heat? Dry air. Understood यहाँ तक? So which is going to cool faster? जिसमें heat नहीं है या जिसमें heat है? Dry air ज़्यादा easily cool करेगी क्योंकि उसमें heat नहीं है. इसीलिए we say dry adiabatic lapse rate is 10 degrees Celsius for every kilometer. Understanding? And the moist air, because it has heat inside, it cools very slowly because water is a greenhouse gas and it is going to trap the heat. And therefore we say moist adiabatic lapse rate is less. समझ में आया concepts of dry and moist adiabatic lapse rate? Because moist air is going to trap the heat. So धीरे से ऊपर जाएगा. वो ऊपर भी जाएगा तो वो इतना easily cool नहीं करेगा because water vapor has the tendency to trap the heat, and therefore it will cool at much smaller pace, much lesser pace. So after 1 kilometer अगर आप measure करते हो तो dry air 10 डिग्री से cool हो गई है, moist air सिर्फ 5.5 डिग्री से cool हो गई है, and therefore there is a concept of dry and moist adiabatic lapse rate. और एयर अगर ऊपर जाती ही नहीं है, एयर रिमेन्स कांस्टेंट, आप ऊपर नीचे जा रहे हो कि चलो ये बोर्ड के नीचे 1 किलोमीटर पे कितनी है टेम्परेचर, 2 किलोमीटर बाद कितना है टेम्परेचर. सो इफ द एयर इज नॉट गोइंग अप एंड डाउन मीन्स देयर इज नो इंस्टेबिलिटी इन द एटमॉस्फेयर, तो पूरा टेम्परेचर चेंज होगा बाय 6.5 डिग्री सेल्सियस फॉर एवरी किलोमीटर. उसमें एयर इज नॉट चेंजिंग, एयर इज कांस्टेंट. सो वी कॉल दिस एज एनवायरमेंटल lapse rate. Why adiabatic lapse rate? These are known as, because you know adiabatic means due to rise or fall, any change in the temperature that either occurs due to ascent or due to descent. Clear with the concepts? Understanding the concepts? Fine. Next point. So in general, the rate of decrease of temperature with the height the rate of decrease of temperature with the height is known as lapse rate. So what is lapse rate? Rate of decrease of temperature with height. अगर rate of understanding, if the temperature now increases with the height, आप क्या कहोगे उसको? Temperature, if it decreases with the height, it is known as lapse rate. If the temperature increases with the height, it is known as negative lapse rate. जो हम term use करेंगे in temperature inversion. We say temperature inversion is associated with negative lapse rate. मतलब the temperature does not decrease with the height. Next point. If there is a stationary atmosphere, there is a stationary atmosphere, the rate of decrease of temperature with the height, is constant at 6.5 degrees Celsius per kilometer. Is constant at 6.5 degrees Celsius for every kilometer, known as environmental or normal lapse rate. Known as environmental or normal lapse rate. On other hand, known as normal or environmental lapse rate. On other hand, if the air is ascending or descending, then it expands or contracts. एयर अगर ऊपर जाएगी एक्सपांड करेगी, एयर अगर नीचे आएगी तो कॉन्ट्रैक्ट करेगी. जब कॉन्ट्रैक्ट करेगी, सी आई टेल दिस वेरी वेरी सुपरफिशियली इन जीएस, मैं तो उल्टा कहता हूँ बहुत बार जीएस में, कि जब एयर ऊपर जाएगी तो कॉन्ट्रैक्ट करेगी इसलिए कूल करेगी, जब एयर नीचे आएगी तो एक्सपांड करेगी इसलिए हीट करेगी. एक्चुअली टोटली उल्टा है, बट यू अंडरस्टैंड जीएस में कोई नहीं पूछेगा, सिर्फ जीएस में क्या पता होना चाहिए, 6.5 डिग्री सेल्सियस पर किलोमीटर इज द एनवायरमेंटल लैप्स रेट. इफ समबडी आस्क द डाउट व्हाई, देन आई गिव हिम दिस, बट याद रखना अब इन ऑप्शनल जब एयर ऊपर जाती है तो एक्सपांड करती है बिकॉज वजन कम हो जाता है। एयर जब नीचे आती है तो कॉन्ट्रैक्ट करती है बिकॉज वेट एंड डेंसिटी ऑफ द एटमॉस्फेयर इंक्रीजेस। जब एक्सपांड करती है एयर तो उसका डेंसिटी इंक्रीज होता है, it becomes rarer, uska density reduces. Because density reduces, therefore conduction does not take properly, and the conduction does not take properly, isliye hame lagta hai the temperature of the air has reduced. Understanding? When the air is coming down, uska density increases, and therefore conduction, transfer of heat by the touch of molecules as well as radiation increases. तो हमें लगता है that air का temperature बढ़ गया. This rate of change of temperature either by ascent and expansion, descent and contraction, without the addition of temperature from outside, is what is known as adiabatic rate of change of temperature. Understanding? Everyone? No doubts? Look at the past year questions iske baad, aaj ke lecture ke baad. Questions are very easy if you understand these topics. And इसमें पढ़ने की ज़रूरत नहीं. This is all about creativity and bit physics. So next, where did I stop? The air which is ascending or descending either expands or contracts respectively. Contracts respectively. When the air ascends, its volume increases. But density decreases. And therefore temperature decreases. Understanding this? Volume increases, density decreases, and therefore temperature decreases. Clear? On other hand, when the air descends, its density increases, and therefore temperature also increases. Understanding? Density will increase, volume will decrease. मैंने इस पूरी हवा को लिया और एक बॉक्स में बंद कर दिया छोटे वाले. So density is going to increase, fine, and therefore temperature will increase. कौन सा? जब डिसेंड करेगा तो हाई प्रेशर. टेम्परेचर इंक्रीज हुआ तो high pressure and low pressure is not associated just with temperature. It is associated with falling of air या rising of air. So यहाँ पे जमीन गर्म हुई इसलिए हवा गर्म होके ऊपर चली गई, लो प्रेशर. ऊपर जाके हवा ठंडी हुई इसलिए उसकी डेंसिटी बढ़ी और फिर वो नीचे आई. नीचे आते आते उसका टेम्परेचर बढ़ रहा है, बट स्टिल उसका टेम्परेचर इतना नहीं बढ़ा जितना इस एयर का बढ़ना चाहिए. कंपैरेटिवली देयरफॉर इट इज हाई प्रेशर. सो हाई प्रेशर एंड लो प्रेशर मतलब क्या? अगर एयर आपके सर के ऊपर जा रही है तो लो प्रेशर. इफ द एयर इज कमिंग एंड सिटिंग ऑन योर, दिस इज हाई प्रेशर, नथिंग एल्स. Because pressure is associated with temperature, but rather than the pressure is associated more with dynamism. Air is it forced to come down? High pressure. Air is it forced to rise up? Low pressure. Fine. Climatology is all comparative. High pressure, low pressure, high. And this comparison can be, ये हो सकता है low pressure because इसका temperature is 0. ठंडा है हमारे लिए, बट उसका टेम्परेचर हो सकता है -20. इसका टेम्परेचर कैन बी 45, उसका टेम्परेचर कैन बी 40. इट इज ऑल कंपैरेटिव. So when in climatology we say the temperature is lesser or the environment is cooler, मतलब वो comparative analysis. 45 40 40 cool हो जाएगा, -20 0 0 warm हो जाएगा. So don't associate it with our idea of heat and cold. दोनों टेयर के बीच का what is the temperature, that is more important. Understanding? Where did I stop? Such type of change of temperature either due to contraction or expansion, such type of change of temperature either due to contraction or expansion is known as adiabatic change of temperature. Adiabatic change of temperature is known as adiabatic, A D I A B A T I C, adiabatic change of temperature. Next, it is of two types. Dry adiabatic change, dry adiabatic change, which उसी में which occurs at the rate of 5.5 degree Fahrenheit, not Celsius, or 10 degrees Celsius per kilometer. Understanding? एयर में मॉइस्चर नहीं है, इसलिए वो हीट ट्रैप नहीं करेगा, इसलिए वो हीट जल्दी जल्दी कूल होगा. Dry adiabatic rate occurs in unsaturated air. Dry adiabatic change occurs in the unsaturated air. Unsaturated means which does not have moisture. Saturated air, you will understand later on, is the air जिसमें relative humidity is 100%. जिसमें humidity is 100%, we will call it as a saturated air. And second, moist adiabatic change. Moist adiabatic change, which occurs in saturated air mass, which occurs in saturated air mass, at the rate of 3 degree Fahrenheit or 6 degrees Celsius per 1 kilometer. Six degrees Celsius per 1 kilometer. Environment is 6.5. This varies between 5.5 to 6. For our calculations, I have taken 6 easily. ये दोनों right है. Calculations कहाँ करने हैं? Stability and instability, that is nothing but calculation वाला part. कब air stable होगी, कब air instable होगी. And that is very simple. So now, कैसे air will behave? Suppose if this is a region, any region, mountain है ये, wind is coming from here, fine, the wind is being forced to rise up. As the wind is being forced, will it cool? Yes. अब suppose if this air is unsaturated, मतलब it is now going to cool initially at the rate of 10 degrees Celsius for every kilometer, fine. अब एयर का मॉइस्चर होल्डिंग कैपेसिटी डिपेंड्स अपॉन टेम्परेचर. जैसे टेम्परेचर कम होगा एयर का मॉइस्चर होल्डिंग कैपेसिटी डिक्रीजेस. टेम्परेचर कब कम हो रहा है? जैसे एयर ऊपर जा रही है. सो इफ दिस इज अ माई एयर, इट इज गोइंग अप, उसका टेम्परेचर इज डिक्रीजिंग एंड देयरफॉर उसका मॉइस्चर होल्डिंग कैपेसिटी इज डिक्रीजिंग. As उसका moisture holding capacity is decreasing, moisture has become 100%. When the moisture becomes 100%, we will call this as a saturated air. So कोई भी air जब वो ऊपर जाएगा, initially if it is unsaturated, later on after some time it will become saturated, it will result into formation of clouds, and once the rainfall occurs, वो जब ऊपर जाएगा, it will go by moist adiabatic lapse rate, initially by the dry adiabatic and later on by moist adiabatic lapse rate. फिर हम कैलकुलेट करते हैं कि अगर this is the environmental lapse rate is 6.5 degree Celsius and dry adiabatic lapse rate is XYZ, तो आगे जाके क्लाइमेट में प्रेडिक्शन किया कैसे किया जाता है? If this air is going upwards और यहाँ पे आके if the air का temperature is lesser than the surrounding environment, मतलब ये एयर नीचे आएगी. If the air का temperature is greater than the surrounding environment, मतलब ये एयर ऊपर जाएगी. जब एयर ऊपर जाएगी, instability. फिर कहा जाता है आपको कि कल बारिश के चांसेस 50% है, 60% है, 90% है. This is how climate predictions are done. But अगर एयर का टेम्परेचर ज़्यादा है और एयर नीचे आने वाली है, तो वो कहते हैं कि मानसून में 2 दिन ड्राई रहेगा. This relationship is between the dry, moist adiabatic lapse rate, dry adiabatic lapse rate and the environmental lapse rate is what is known as stability and instability of the atmosphere. Getting it? Stability, dry conditions. Instability, wet conditions. Because air जितना ऊपर जाएगा उतना cool होगा, उतना water vapor will become water या ice. जितना water and ice उतना air का वजन बढ़ेगा, जितना एयर का वजन बढ़ेगा उतना वो नीचे आएगी तो इट विल गिव रेनफॉल या स्नोफॉल. फाइन. नेक्स्ट पॉइंट, द रिलेशनशिप बिटवीन adiabatic change of temperature and environmental rates, an environmental lapse rate determines atmospheric stability and instability. Understood? Before I go further, this is what is known as latent heat of evaporation. And उल्टा हो जाएगा तो it is known as the latent heat of condensation, and this is what is known as fusion. Not much important, हमारे लिए यही important है for, and we'll directly use now this in tropical cyclones. Clear? factors affecting temperature. सबसे important is the latitudes. Do this even for GS very properly. That is, the temperature decreases from lower latitudes to higher latitudes in the bracket, that is from equator to poles, right? Why? Because sun's rays become more and more inclined, right? And inclined sun rays, you know that they, ये सब लिखने की ज़रूरत नहीं, सिर्फ दिमाग में रहने दो. Inclined sun rays pass through larger areas, उसमें more loss of heat is there, they fall over a larger area, pass a greater distance, therefore, clear? This is also you have studied in GS, is equator. क्यों? क्योंकि equator regions में there is a everyday rainfall, and rainfall के लिए there has to be clouds, and clouds will have albedo, so insolation will decrease. So where will be the highest temperature? Highest temperature is always found between 30 to 35 degree north and south, which is known as subtropical high pressure belt or horse latitudes. Is it visible properly? Highest temperature, we should have, मेरे यहाँ पे अलग कलर दिख रहा है इसलिए, is not over equator, because of daily rain and cloud cover. So the highest temperature, this is the highest temperature written, is between just to the north and the south of the equator, 30 to 35 degree north and south, which is known as subtropical high pressure belt, जिसको हम कहेंगे. इसका मतलब ये है कि the highest temperature is not in this region between 0 to 5. That is, highest temperature of India will never be in Kerala, Andaman and Nicobar Islands. चाहे उसमें पूरे साल गर्मी रहेगी, but when the summers will come, highest temperature will be in this belt, northwest India, Delhi, Rajasthan, Punjab, subtropical high pressure belt. Why? Because these are the regions जहाँ पे हाई प्रेशर है. हाई प्रेशर है, हवा नीचे आ रही है. हवा जब नीचे आती है तो क्लाउड्स नहीं होंगे. क्लाउड्स के लिए हमेशा एयर शुड राइज अपवर्ड्स, एंड क्लाउड्स नहीं होंगे तो नो रेनफॉल, सो डायरेक्टली सनलाइट विल कम एंड हिट. फाइन. Second factor that determines the temperature is altitude. This has already been your past year question. Altitude. And altitude determines what is known as a vertical distribution of the temperature. And now when we are doing the temperature, yaad rakho, we consider air is constant, fine. So vertical distribution of temperature mein hamesha likhna that the temperature decreases at the rate of 6.5 degrees Celsius per kilometer, which is known as environmental lapse rate. Kyun? Teen reasons, dimag mein rakho. What is the source of heat of the atmosphere? 86% of the atmosphere is heated by terrestrial radiation. 14% by insolation. So source is the earth itself. जब आप ऊपर जाते हो, you are moving away from the source of the heat, and therefore you are moving away from the heat, and therefore temperature will decrease. जैसे हम ऊपर जाएंगे, अभी हमने देखा, the air will become rarer and rarer, and therefore conduction will not occur, and hence the temperature is going to decrease. Third, most of the greenhouse gas, water vapor, is present only up to the height of 120 kilometers. जिसमें से 90% of the water vapor is found below the height of 5 kilometers. Maximum water vapor 120, fine, but 90% the water vapor is found below the height of 5 kilometers. To be exact, अगर समिंद्र संघ को ही कोट करना है, 95% of the water vapor is found below the height of 2.9 kilometers. 90% is found below the height of 5 kilometers. मतलब बचा हुआ 5% of water vapor है, वो है बचे हुए height में. Carbon dioxide mostly is in the troposphere, that is in the lower troposphere, fine, and therefore greenhouse gas, that is the capacity of the gases to trap the heat, decreases as we go up, and therefore we can say that temperature decreases at the rate of 6.5 degrees Celsius as we go up. Clear with this? Why the temperature decreases with the increasing height? Whether it is dry adiabatic, whether it is moist adiabatic, जैसे हम ऊपर जाएंगे, ये कभी मत सोचना कि हम तो सूरज की तरफ जा रहे हैं. The temperature should increase. No. Temperature is going to increase as you go near the sun, but once you cross the Earth's atmosphere is like a filter, which will not allow the rays to come inside. Fine? Altitude. So you can take down 2-3 points. Have you done this all in GS? Fine? कहाँ मेरे क्लासेस ही कहाँ हुए? Vertical distribution of temperature, altitude. So मैं directly option के हिसाब से आंसर दूँ. The vertical distribution of temperature. Vertical distribution of temperature. Determined by lapse rate, comma condensation, caused due to either environmental lapse rate or adiabatic lapse rates. Or adiabatic lapse rate is primarily due to three factors. One, moving away from the source of the heat, that is the earth. moving away from the source of the heat, that is the earth, and consequent decrease in the terrestrial radiation with the height, and consequent decrease in the terrestrial radiation due to height. Second, decrease in the density and hence conduction, and third, decrease in the capacity of the atmosphere, to retain the heat, due to decrease in the greenhouse gases. This decrease of temperature with the increasing height, occurs in troposphere and mesosphere. But in the stratosphere, due to the presence of UV radiations, some amount of terrestrial radiation, underline the word some amount of terrestrial radiation, but the larger part of insolation is trapped, and hence temperature increases. The general distribution of vertical distribution of temperature with increasing height, can be shown with the diagram below. देखो ट्रोपोस्फियर, द लोअर मोस्ट लेयर, टेम्परेचर 21 से डिक्रीज होते होते 16 किलोमीटर, व्हाट इज द मैक्सिमम लिमिट, या 18 किलोमीटर, इट बिकम्स -60 डिग्री सेल्सियस, फाइन। उसके बाद द रेट ऑफ डिक्रीज ऑफ टेम्परेचर स्टॉप्स, इसको हम कहेंगे ट्रोपोपॉज, जहाँ पे ट्रोपोस्फियर खत्म होता है। आफ्टर दैट, ड्यू टू द प्रेजेंस ऑफ यूवी रेडिएशंस, द टेम्परेचर गोज ऑन इंक्रीजिंग। दिस इज द मोस्ट स्टैंडर्ड डायग्राम। द रियल डायग्राम इज टेम्परेचर बहुत ज़्यादा इंक्रीज होगा यहाँ पे और उसके बाद स्टेबल हो जाएगा। But we don't draw the real diagram, we draw the standardized diagram, because ozone gas is concentrated only in the lower stratosphere, and इसलिए temperature of lower stratosphere is obviously greater than that of upper stratosphere. But हम इस diagram में उल्टा दिखाते हैं, you don't have to go into so much details. The temperature goes on increasing. So -60 से it becomes around 0 degree Celsius. Getting it? उसके बाद the rate of increase of temperature stops. Again the temperature goes on decreasing from 0 degree Celsius, it becomes -80 degree Celsius in the third layer, which is known as mesosphere. और उसके बाद वो स्टॉप हो जाता है, and this is the end of inner atmosphere जिसमें gases है। उसके बाद सिर्फ ions है, and ions are always charged, इसलिए temperature सीधा increase होता है और बहुत ज़्यादा हो जाता है। So this is what is the vertical distribution of temperature. अगर ऑप्शनल में आता है तो, जीएस में अगर आता है तो ट्रोपोस्फियर तक खत्म कर दो, ऑप्शनल में अगर आता है तो यू विल हैव टू राइट एवरीथिंग, दैट इज कंपोजिट स्ट्रक्चर ऑफ द एटमॉस्फेयर। ideally यहाँ से यहाँ तक the temperature should have gone on decreasing, but ideally नहीं है, because यहाँ पे there is a, it goes on decreasing and suddenly it encounters the ozone gas which will trap the UV radiations which is found in entire stratosphere, but उसका maximum concentration is till the height of 30 kilometers. So इसलिए यहाँ पे temperature increase होता है. फिर से जैसे ही ओजोन खत्म होता है उसका टेम्परेचर डिक्रीज होने लगता है. अंडरस्टैंडिंग? डिपेंडिंग अपॉन कौन से रेडियो वेव्स रिफ्लेक्ट होंगे, वी डिवाइड दिस इनटू डी लेयर, ई लेयर, एफ लेयर एंड जी लेयर. सो डी, ई, एफ एंड जी लेयर. Because ionosphere, this is used for radio communication because it has charged particles known as ions, right? इसका name is troposphere because यहाँ पे air का movement है, winds. It is known as stratosphere because it is at second number. Strato means 2. It is known as mesosphere because it is middle layer. It is known as ionosphere because it has presence of ions. It is the outermost layer, therefore it is known as exosphere. So mesosphere is between these two and these two layers, इसलिए mesosphere, which is the coolest layer of the atmosphere. होमोस्फीयर क्यों? क्योंकि मोर और लेस गैसेस एक जैसे ही है वो नीचे के लेयर में. ऊपर का लेयर हेट्रोस्फीयर क्यों? क्योंकि यहाँ पे ऑक्सीजन ही मिलता है. उसके बाद 120 किलोमीटर के बाद सिर्फ नाइट्रोजन मिलता है, उसके ऊपर सिर्फ हाइड्रोजन मिलता है और ऊपर में सिर्फ हीलियम मिलता है. सो ईच एंड एवरी लेयर इज डिफरेंट. दिस इज नॉट द केस. यहाँ पे देयर इज नाइट्रोजन मिक्स्ड विथ ऑक्सीजन मिक्स्ड विथ कार्बन डाइऑक्साइड एक्सेट्रा. Therefore, there is a homogeneous mixture of gases, homosphere. All the layers are different, therefore heterosphere. But obviously, optional में इन सब चीज़ों का काम नहीं. This is too basic for optionals. Fine? But do this properly in general studies. This is what is the GS. What is inner atmosphere? Mesosphere के नीचे वाला. What is the outer atmosphere? Mesosphere के ऊपर वाला. What is this line which divides the inner and outer atmosphere known as? It is known as करमान लाइन और लेयर. इनर एंड आउटर एटमॉस्फेयर के बीच की बाउंड्री. जैसे ही एनी एक्स्ट्रा टेरेस्ट्रियल ऑब्जेक्ट एंटर्स द करमान लेयर, गैसेस की डेंसिटी, मतलब एटलीस्ट सम गैसेस आर प्रेजेंट हियर, सो द डेंसिटी ऑफ द एयर इंक्रीजेस. एंड इसीलिए इन दिस रीजन देयर इज meteors का शावर इन द मेसोस्फीयर. Getting it? Ionosphere radio communication के लिए. There is a meteor का shower in the mesosphere. Fine? And tropo मतलब mixing, sphere मतलब area, जहाँ पे mix हो रहा है air. कैसे mix हो रहा है? बाकी सब मत बनाओ. Just try to I can continue, right? कैसे mix हो रहा है? Either by the process of convection or either by the process of winds, surface winds, or either by the process of jet streams. So हमेशा यहाँ पे mixing है, या by the process of clouds formation, This is what is occurring. And therefore, you have done that commercial aircrafts will always flow in tropopause या in the stratosphere. Why? क्यों? क्योंकि वहाँ पे हवा नहीं है. And therefore, they don't have a problem of turbulence. They don't have a problem of the resistance of air. Getting it? So this is all GS. Fine. Next point. But sometimes only in the troposphere, the air instead of cooling with the increasing temperature, air instead of cooling with the increasing height, experiences heating. These conditions which are different from the normal, characterized by negative lapse rate, where the warmer air lies above the cooler air. Where the normal air lies above the cooler air is known as temperature inversion. And this diagram you can draw. See, on the x-axis we have temperature. Temperature goes on increasing here. On the y-axis we have height. In the normal condition, temperature कम होते जा रहा है. But in the abnormal condition, temperature कम हुआ, but थोड़ी देर के लिए temperature बढ़ा, and then फिर से कम हुआ. So this region is what is known as zone of temperature inversion. Inversion layer. होप कन्फ्यूजन नहीं है, बिकॉज हम कैसे करते हैं इन जीएस, हम पहले स्ट्रक्चर अलग से पढ़ते हैं, कंपोजिशन अलग से पढ़ते हैं, फिर सारे फैक्टर्स करते हैं इजी वे, फिर एक टॉपिक खोलते हैं टेम्परेचर इन्वर्जन. यहाँ पे मैंने वर्टिकल के साथ साथ ही टेम्परेचर इन्वर्जन किया है. अंडरस्टूड? Had this been GS class, I would have taught. I would have started yesterday, last lecture, स्ट्रक्चर एंड कंपोजिशन, नाइट्रोजन कितना परसेंटेज है, ऑक्सीजन कितना है, ग्रीन हाउस इफेक्ट क्या है, देन स्ट्रक्चर क्या है, होमोस्फियर क्या है, हेट्रोस्फियर क्या है, फाइन। देन में आता इंसोलेशन पे, फैक्टर्स अफेक्टिंग इंसोलेशन क्या है। देन में आता टेम्परेचर पे, और हम पहले 10 फैक्टर्स पढ़ते, अल्टीट्यूड, लैटिट्यूड, डिस्टेंस फ्रॉम द सी, डिफरेंस बिटवीन द नेचर ऑफ लैंड एंड वाटर, राइट। फिर हम पढ़ते वर्टिकल डिस्ट्रीब्यूशन, फिर हम पढ़ते टेम्परेचर इन्वर्जन। यहाँ पे हम सब वो फॉलो नहीं कर रहे, गेटिंग इट? बट आर यू अंडरस्टैंडिंग द मेन कंसेप्ट्स? टेम्परेचर इन्वर्जन। सो क्या होगा टेम्परेचर इन्वर्जन में? एज वी गो अप द टेम्परेचर विल कूल और increase. In the normal condition, as we go up, the temperature should decrease. कहाँ पे हो रहा है temperature inversion? Entire atmosphere में या only in the troposphere? Only in the troposphere. You cannot say this as a temperature inversion. Stratosphere में obviously temperature is going to decrease. But यहाँ पे instead of temperature decreasing, अगर slightly temperature increase हुआ very near to the ground, हम इसको कहेंगे temperature inversion. So this diagram applies only to this region. Fine? It does not apply to this region. It does not even apply above. Only near the ground. So ऊपर की हवा, यहाँ की हवा टेम्परेचर इन्वर्जन में रिमेंबर इज कोल्ड. ये लिखो मत, ये सिर्फ समझो. दिस इज कोल्ड. फाइन. दिस इज warm. This is again cold. In the normal conditions, this is comparatively warm. This is cool. This is cooler. Because in the normal conditions, warm air, नीचे की air is warm, वो ऊपर जाएगी. But in the temperature inversion conditions, नीचे की air cold है, वो ऊपर क्यों जाएगी? It is already denser. Denser air हमेशा नीचे आएगी. Therefore, temperature inversion is always associated with dry conditions. And normal conditions में air ऊपर जाएगी तो वो clouds बनाएगी, etc. And it may give the rainfall. But in the temperature inversion conditions, नीचे cold air है, ऊपर warm air है. The cold air will cool the warm air from below. And therefore, warm air में जो भी water droplets है, they will start getting cooled and they will result into formation of a structure here, a low lying structure, जिसको we will call it as fog. Temperature inversion will always result into fog, dew, frost. Normal conditions, if this warm air rises up, it will result into clouds, snow, rain. And if it is extremely abnormal condition, तो फिर air will go up and this will result into cyclone, tornado, whatever, cumulonimbus cloud, etc. Getting it? If it becomes very, very warm. Understanding? The next factor is, now this factors very quickly ताकि हमें सिर्फ इथेनोमोलस टेम्परेचर समझ में आ जाए. Distance from sea of any place, fine, or distance from the water body. Suppose this is the place. And see, कभी कभी ऐसे क्वेश्चंस आते हैं. Look at the past year questions. This also come in the exam. Except for geomorphology, बाकी यूपीएससी में many questions will look like GS का questions, but then make very proper answers. अगर आता है क्वेश्चन फैक्टर्स अफेक्टिंग टेम्परेचर, डिस्ट्रीब्यूशन ऑफ टेम्परेचर, बहुत ज़्यादा खुश होके जल्दी जल्दी में मत लिखना. यस, इजी क्वेश्चन है, वो 100% अटेम्प्ट होना चाहिए. बट कैसे अटेम्प्ट होना चाहिए कि यू शुड गेट मिनिमम 65% ऑफ द मार्क्स इन दैट क्वेश्चन, दिस शुड बी योर टारगेट। सो उसके लिए डेफिनेशंस, डायग्राम्स, कुछ तो एक्स्ट्रा बताना। So the place which is nearer to the sea, there are two places in our diagram here, the place A and the place B. The place B is very, very far away from the sea. The place A is very near to the sea. It is a coastal city. Now what happens in the place A? During the daytime, you know there is a difference between the nature of land and water. Land will cool and heat at a very fast rate. Water will take time to get heated and to get cooled. Reason is matter अलग है, सनरेज लैंड के अंदर पेनिट्रेट नहीं करेंगे, वाटर के अंदर पेनिट्रेट करेंगे। वाटर के अंदर पेनिट्रेट करने के बाद वाटर एक जगह रहेगा नहीं, वो ओशन करंट्स जाएंगे एक दूसरे से, दैट विल रिजल्ट इनटू मूवमेंट ऑफ द हीट इनसाइड द वाटर, फाइन। But land where there is no movement of the heat, etc., and as a result of this, land will get heated and cooled at a very fast rate. During the daytime, as the same amount of insolation is falling on the land and the sea, land will get वैसे भी more insolation because sea always has cloud cover as there is evaporation. So during the daytime, low pressure will fall on the land because यहाँ की air will get warm. It will start rising upwards. Surrounding water body will be under the high pressure. And therefore, moderating wind will come to place A in the form of sea breeze. Now, the extent of this local wind such as sea breeze and the land breeze is maximum, worst case scenario, maximum 60 kilometers. वैसे उसका extent in many countries is around 20 kilometers interior तक. So they will never reach place B. The place B can be Mumbai, the place A can be any coastal city. Sorry, the place B can be Delhi, place A can be any coastal city. It can be Thiruvananthapuram, it can be Mumbai, anything. During the night time, sun sets, land अपनी heat जल्दी छोड़ देगा, water will trap the heat. And therefore, रात में land will develop a high pressure, water will be comparatively at low pressure, and therefore रात में there will be a breeze which flows from sea towards the land towards the sea in the form of which breeze? Land breeze. So इसके कारण there will be redistribution of heat, and this redistribution of heat will make sure that यहाँ का temperature always stays moderate. But यहाँ का temperature, because of no redistribution of the heat, will be extreme. So summers will be very hot, winters will be very cool. यहाँ का temperature will be moderate due to daily land and sea breeze. Getting it? यहाँ का temperature will be extreme. So this phenomena is what is known as maritime climate या maritime influence. And this phenomena is what is known as continental impact. इसका एग्जाम्पल इज नॉर्थ इंडिया वर्सेस साउथ इंडिया. सदर्न इंडिया में कभी भी एक्सट्रीम क्लाइमेट नहीं हो सकता इन द कोस्ट. नॉर्थ इंडिया में देयर विल बी वेरी एक्सट्रीम क्लाइमेट नियर द कोस्ट. अंडरस्टैंडिंग द लैंड एंड सी ब्रीज. अब टेल मी, कैन वी चेंज दिस लैंड एंड सी ब्रीज? Can human beings affect this land and sea breeze? How we can affect the land and sea breeze का impact? Cities, urban heat island, जिसका temperature will be greater. So दिन में तो sea breeze होगा, but रात में ये भी low pressure, ये भी low pressure, and क्या गायब हो जाएगा? The land breeze. And land breeze गायब हो जाएगा तो क्या प्रॉब्लम होगा? The rather than maritime influence, rather than moderating impact, you remember the land breeze and sea breeze greater impact is land breeze removes the pollutants from the city. But this thing is going to miss from many cities due to the urban heat island. Example, 2018 December to 2019 March, Kolkata, Mumbai experienced the similar air quality for the first time as Delhi. That is air pollution. क्यों? Land breeze गायब है. क्यों गायब है? Urban heat island effect. Getting it? Understanding? नहीं तो अभी तक क्या यूपीएससी ने एक बार क्वेश्चन भी पूछा है, व्हाई आउट ऑफ ऑल द मेट्रोज इन इंडिया दिल्ली इज द मोस्ट पोल्यूटेड. अब ये यूपीएससी क्वेश्चन नहीं पूछ सकती बिकॉज मुंबई एंड कोलकाता आर ऑल्सो शोइंग द सिमिलर लेवल, ऑब्वियसली इतना गंदा नहीं जितना दिल्ली का है, बट सिमिलर लेवल्स ऑफ पोल्यूशन. गेटिंग इट? And see, pollution तो अभी you will realize what is Delhi का pollution. Wait for 2 months. Can I continue? One statement here. The diurnal मतलब डेली. Diurnal means daily. Local winds in the form of land and sea breeze. Local winds in the form of land and sea breeze. Moderates the maritime climate or moderates the coastal climate. Moderates the coastal climate. Comma. Reduces pollution. And therefore, both daily and annual range of temperature daily and annual range of temperature is less in the coastal regions. Delhi and the annual range of temperature is less in the coastal regions. But the continental interiors will have high annual range of temperature, as well as extreme climate due to lack of land and sea breeze. See, मुझे इसमें थोड़ा चेंज करना है. I will give this tomorrow. जिसको डिटेल में पढ़ना है, you go through this handouts. Right? Large land means lakes. Yes, obviously, even near the everything is given here. Distance from the sea, ocean currents, altitude above the sea level, etc. Only thing is थोड़ा इसमें diagrams डाल के आपको देना है. So I'll give that tomorrow. So, but use this only for reference, not for study purpose. If you don't understand anything, then use this. Now your question is, can this happen in the regions where there are big lakes? It will happen even in the regions of the smaller lakes. Suppose if your house is in the interiors, but if your house is near the river, you will have moderating effect as compared to the interior. Forget lakes. All the houses which are surrounding the gardens in Rajendra Nagar will have comparatively moderate region as compared to do gali piche. So it happens, the only thing is scale matters. The scale is bigger, that scale is smaller. See, those people who believe in Vastu or Feng Shui, etc., they say to change your luck, put water with salt in eastern corner of your room. Then your luck will change, your health will improve, and you will get money. What is the logic behind Feng Shui? Logic behind Feng Shui is, in the eastern corner of room, if the sun rays are coming, there will be evaporation. With the evaporation, the air will become inside the room moist. Moist air does not support aerosols. Aerosols are removed by the moist air. Dry air, there are more number of aerosols. Jitna zyada aerosols, utna zyada allergy. Moist air mein no aerosols, less bacteria, less formaldehyde, less benzene. So it all depends upon scale. The same thing is happening even in the room under the Feng Shui. Fourth, difference between nature of land and water. This is the fourth factor that affects the temperature. All this applications, do this very properly today, understand this. Isi ka application is entire climate. Monsoons is due to this. Fine, Siberian type of climate is due to this. Temperature inversion is due to this. So what is the difference between the nature of land and water? That is, water will get heated up or cool very slowly, while land will get heated and cools fast. So question is why? So why ka answer is, can I continue? Why ka answer is here. Sun rays cannot penetrate very deep inside the land. So as a result of this, they will heat up only the superficial layer of the land. While in the water body, the sun rays will penetrate up to the depth of 200 meters. That is this. So it has to heat up more area as compared to the land. Secondly, after heating up, land will stay at the same place, but this water will move in the form of ocean currents, waves, tides. Fine. Thirdly, land cannot get evaporated. Water, if it gets evaporated, it will start rising up and it will result into formation of clouds. And therefore, this is the, we say, the specific heat of water is more than that of a land. So the answer for here is specific heat of water is more than that of a land. Specific heat. What do you understand by the specific heat? Technically, specific heat is the amount of heat that is required to raise the temperature of 1 gram of any substance by 1 degree Celsius. So, to raise the temperature of 1 gram of land versus 1 gram of water, किसमें ज़्यादा heat देना पड़ेगा मुझे? Water में, because land will get heated very quickly. The same thing, to make a tea, you first have to heat up the pot, land. Then after some time, नीचे का part of that vessel or milk or boiling water starts getting heated up. फिर it starts becoming less denser. Because it becomes less denser as compared to the upper part of the water, बर्तन में वो ऊपर की तरफ जाता है. वो जैसे ऊपर की तरफ जाता है, यू सी कन्वेक्शनल करंट्स. फिर जैसे ऊपर की तरफ जाता है, ऊपर का डेंसर वाटर नीचे आता है. नीचे आके वो बर्तन के नीचे, इट टचेस द बॉटम ऑफ अ पॉट. बॉटम ऑफ पॉट के नीचे गैस चल रहा है, एंड दिस गिव्स राइज टू कन्वेक्शनल करंट्स इनसाइड द वेसल. एंड इसीलिए बहुत देर के बाद टी बनेगा. देन यू पुट इट इन द कप. इनिशियली कप बहुत गर्म हो जाता है, यू डोंट टच इट, बट आफ्टर वेटिंग फॉर 30 सेकेंड्स और 1 मिनट कप ठंडा हो जाता है, अंदर का चाय गर्म ही रहता है. 15 मिनट बाद कप टोटली ठंडा हो जाता है, अंदर का चाय ल्यूक वार्म होता है. गेटिंग इट? वाटर विल टेक टाइम टू गेट हीटेड एज वेल एज कूल. सो व्हाई? बिकॉज स्पेसिफिक हीट. आई डोंट हैव टू गिव द डेफिनेशन ऑफ स्पेसिफिक हीट. फाइन. रीजन is, remember, 3. 1, in water. Second is heat is redistributed in the form of ocean currents, waves, tides, etc. No such redistribution on the land. And the last factors, which I will combine all the factors, is winds, weather conditions, and ocean currents, etc. Jahan there is a Gulf Stream like warm ocean current, we have greater temperature. So these are the factors that determine the temperature. Getting it? Cloud cover, slope, the slopes which face the sun will be more heated, the slopes which do not face the sun will be less heated. Example, southern slopes of Himalayas. थोड़ा difficult example है, just imagine. How are Himalayas? East-west mountains or north-south mountains? East-west mountains. So because they are east-west mountains, if this is India, ये है Tropic of Cancer, जहाँ तक sun जा सकता है. This is how the Himalayas. So this is the southern slope, This is the northern slope. This southern slope will always face the sun. The northern slope will never face the sun because sun का maximum rays vertical कहाँ तक है? Till the Tropic of Cancer. We have just seen. Tropic of Cancer के ऊपर कभी sun जाता नहीं है. सन नहीं जाता मतलब अर्थ ऐसे रिवॉल्व नहीं करता कि दैट सन विल क्रॉस द ट्रॉपिक ऑफ कैंसर. इसलिए सदर्न स्लोप्स ऑफ द हिमालयाज. एप्लीकेशन इंडियन ज्योग्राफी. एप्लीकेशन जीएस प्रीलिम्स. विच पार्ट ऑफ द हिमालयाज हैव मोर स्नो कवर, नदर्न या सदर्न? नदर्न. विच पार्ट इज ऑफ द हिमालयाज इज मोर डेंसली वेजिटेटेड, नदर्न या सदर्न? सदर्न. गेटिंग इट? स्नो लाइन, स्नो कवर, ये सब. So can I say that the temperature will more or less follow the regional distribution? Okay, more or less near the latitudes there will be more or less the same temperature. Around the tropics the temperature ka range will be more or less same. Fine. And with this background we come to the concept of ईशानोमोलस टेम्परेचर और एनामोलस टेम्परेचर. Anomalous temperature. What is anomalous temperature? What is anomaly? What is the word anomaly? Difference from the regular pattern. So किसी जगह एवरेज टेम्परेचर होना चाहिए 10 डिग्री सेल्सियस, बट उस जगह का एवरेज टेम्परेचर है 30 डिग्री सेल्सियस ड्यू टू सेपरेट सम रीजंस. सो ज़्यादा है या कम है फ्रॉम द रेगुलर? The average temperature of a place should be 10 degrees Celsius, but due to some reasons, the average temperature of one particular place in that latitudes, average temperature of वो पूरा latitude is 10 degrees Celsius, but due to some reason, the average temperature of a particular place in that latitude is 30 degrees Celsius. What it is? More than the average या less than the average? More than the average. It is known as positive anomalous temperature. If it is 0 degree Celsius और average होना चाहिए 10 degree Celsius, then it will be known as negative anomalous temperature. क्यों हो सकता है anomaly? Tell me whether he is right or wrong. There is a place which is located at 50 degree latitudes anywhere in the northern hemisphere जहाँ पे temperature of a place should be 18 degree Celsius, but a warm ocean ये पूरे region में, this is the coastal place, place A. There is a place B, there is another place, place C. It is again the coastal place, but यहाँ पे आता है Gulf Stream or North Atlantic Drift, warm ocean current. Will it increase the temperature or decrease the temperature? Increase. Positive anomaly. यहाँ पे है cold ocean current, Labrador current. Will it increase the temperature or decrease the temperature? Or B, it is very very far away from the coast. So summers will be very very hot and winters will be very very cold. फिर भी anomalous हो गया, right? This is what is known as an anomalous temperature. Actually, anomaly is because we make a world map. इस world map में हम कहते हैं कि these are the tropics, tropics में ये होना चाहिए, these are the temperate में ये होना चाहिए, इस latitude से इस latitude तक temperate region है, इस latitude से इस latitude तक there is a tropical region, etc. And then when we see the real conditions, we see that real conditions are very different from the normal. Why? Because of host of factors. Host of factors can be, there is a big mountain which is not allowing the winds to come. The place may be coastal and it may have either warm currents or the cold currents. And therefore, this deviation of a temperature from the normal conditions is what is known as thermal anomaly or anomalous temperature. Fine. इसके लिए आपको सिर्फ एग्जाम्पल्स पता होने चाहिए. ओशनोग्राफी के एग्जाम्पल, वार्म करंट, कोल्ड करंट का, और सेकंड एग्जाम्पल फैक्टर्स अफेक्टिंग टेम्परेचर में से डिस्टेंस फ्रॉम द कोस्ट. if the region is very far away from the coastline, then वहाँ पे there will be extreme of climate. Example, Siberia. Fine. So Siberia, that is the eastern part of Siberia, especially Russia. Russia is a very big country. This is Russia. Which part of the Russia is habited? These are Urals, and most of the Russia which is habited is here. यहाँ पे रहते हैं लोग? No. It is very few people stay in this region. क्यों? नीचे चाइना है, यहाँ पे बाल्टिक सी है, यहाँ पे आर्कटिक सी है. This is Europe. ठीक है, फिर भी moderate climate है. But यहाँ पे in this interiors, this is Siberia, one of the most dangerous place in the world, because summers में temperature is so high that temperatures of around 35 degrees Celsius to 40 degrees Celsius is very normal. And winters में it is so cold that temperatures of -60 to -55 degrees Celsius is very normal. Many people who come to Delhi from peninsular India, December में भाग जाते हैं घर पे, क्योंकि Delhi becomes very cold. Imagine the conditions how people live in this region. This is what is the anomalous temperature. Why? Because of the continental interiors. Fine. There are many people, you will see this in December. ठंड बहुत है, मेरे को बर्दाश्त नहीं हो रही. कितना टेम्परेचर है? अगर पेनिनसुला में विंटर्स में 25 डिग्री सेल्सियस है, तो दिल्ली में सिर्फ 5 डिग्री है ज़्यादा से ज़्यादा. 20 डिग्रीज इज लेस. यू सी द वेरिएशन. फाइन. So anomaly, anomalous temperature. The average temperature of a place, the average temperature of the place is determined with the help of isotherms, that is the lines joining places of equal temperature. Lines joining the places of equal temperature. With the help of latitudes and isotherms, modern as well as classical geographers, have divided the earth into three major zones. Have divided the earth into three major zones. As tropical zone, tropical zone. Tropical zone between 23.5 degree north and south, between 23.5 degree north and south, where the average temperature of a place, where the average temperature of the place is always greater than 25 degrees Celsius, always greater than the 25 degrees Celsius. Temperate zone between 23.5 degree latitudes to 66.5 degree latitudes. Where there is a seasonal variation in the temperature. Where there is a seasonal variation in the temperature. But it varies between 18 to 25 degrees Celsius. It varies between 18 to 25 degrees Celsius. And lastly, frigid zone beyond 66 degree latitudes polewards, beyond 66 degree latitudes polewards, where the temperature is always below 10 degrees Celsius. Where the temperature is always below 10 degree Celsius. Fine, you can use this diagram. Can I continue? So India dekho is like this. Right now our class is going on in temperate zone. Next point. But when the focus is on studying the temperature differences Studying the temperatures differences of a place as compared to the respective latitudes, as compared from the respective latitudes, it is known as anomalous or isanomalous temperature. It is known as anomalous or isanomalous temperature. It is known as anomalous or isanomalous temperature. Next point, Oliver and Hedor have defined anomalies as the deviations from the normal. ये नाम आने चाहिए, Oliver and Hedor have defined anomalous temperatures as the deviation from the normal. Example, if the average temperature of a particular latitude, example या next point जैसा लिख लो, if average temperature of a particular latitude is 20 degrees Celsius, and if the temperature of a particular place A, located on that latitude is 30 degrees Celsius, temperature of a place A is 30 degrees Celsius, then the thermal anomaly, क्या होगा, positive or negative, is positive thermal anomaly. Give me an example. Draw a diagram. हमें एग्जाम में आंसर लिखना है, वैसे तो कंसेप्ट में कुछ भी नहीं है. नॉर्मल आदमी को बताने के लिए ये आज 1 मिनट का काम है, जो भी नॉर्मल है उससे ज़्यादा या कम, फाइन. बट आंसर लिखने के लिए गिव मी एन एग्जाम्पल, शो, थिंक ऑफ द डायग्राम, दिमाग में आनी चाहिए. देयर हैज बीन ना, यस, इंग्लैंड वाला रीजन. बस कुछ नहीं, इट्स ऑल अबाउट, क्लाइमेट इज ऑल अबाउट प्रेजेंटेशन. बहुत बार तो बोर हो जाओगे कि क्या जीएस पढ़ा रहे हो, अनलेस क्लास है. अभी कितने बजे? कितने बजे? 5 मिनट, 10 मिनट. कल भी है डिस्कशन, आज ही है, ठीक. Fine. So warm ocean current. Example is the northwest European type of climate. a northwest European type of climate. Experiences higher temperature, experiences higher temperature than the places in the same latitudes. Places in the same latitudes due to warm ocean currents. Due to warm ocean currents. I'll stop here, we'll meet tomorrow. There is a class discussion. और एग्जाम्पल्स ऐसे सोचो, इंडिया के एक दो एग्जाम्पल सोचो. नेगेटिव क्या होगा? जहाँ कोल्ड करंट्स है या एक्सट्रीम क्लाइमेट है. फाइन. लुक एट दिस प्लेस बिफोर आई लीव. जितने एग्जाम्पल्स यूज कर सकते हैं जीएस से यूज करो. Is the temperature of Delhi same as the temperature of Arunachal Pradesh? Latitude तो same है. Why? Location. Continental, interiors, Himalayas height, temperature has decreased. ये भी second example हो सकता है. Getting it? So examples, nothing else.